Lesson 2. Energy Transformations. Reading Guide. Key Concepts. What is the law of conservation of energy? How does friction affect energy transformations? How are different types of energy used? Vocabulary. Law of conservation of energy. Friction. Inquiry. What's that sound? Blocks of ice breaking off the front of this glacier can be bigger than a car. Imagine the loud rumble they make as they crash into the sea. But after the ice falls into the sea, it will gradually melt. All of these processes involve energy transformations, energy changing from one form to another. Changes between forms of energy. It is the weekend, and you are ready to make some popcorn in the microwave and watch a movie. Energy changes form when you make popcorn and watch TV. As shown in Figure 5, a microwave changes electric energy into radiant energy. Radiant energy changes into thermal energy in the popcorn kernels. The changes from electric energy to radiant energy to thermal energy are called energy transformations. As you watch the movie, energy transformations also occur in the television. A television transforms electric energy into sound energy and radiant energy. Changes between kinetic
Come on. Sorry. Take 2 days to load.
Changes between kinetic and potential energy. Energy transformations also occur when you toss a ball upward, as shown in Figure 6. The ball slows down as it moves upward and then speeds up as it moves downward. The ball's speed and height change as energy changes from one form to another. Kinetic energy to potential energy. The ball is moving fastest and has the most kinetic energy as it leaves your hand, as shown in Figure 6. As the ball moves upward, its speed and kinetic energy decrease. However, the potential energy is increasing because the ball's height is increasing. Kinetic energy is changing into potential energy. At the ball's highest point, the gravitational potential energy is greatest, and the ball's kinetic energy is the least. Potential energy to kinetic energy. As the ball moves downward, potential energy decreases. At the same time, the ball's speed increases. Therefore, the ball's kinetic energy increases. Potential energy is transformed into kinetic energy. When the ball reaches the player's hand again, its kinetic energy is at the maximum value again. Reading check. Why does the potential energy decrease as the ball falls? The law of conservation of energy. The total energy in the universe is the sum of all the different forms of energy everywhere. According to the law of conservation of energy, energy can be transformed from one form into another, or transformed from one region to another, but energy cannot be created or destroyed. The total amount of energy in the universe does not change. Key concept check. What is the law of conservation of energy? Friction and the law of conservation of energy. Sometimes it may seem as if the law of conservation of energy is not accurate. Imagine riding a bicycle, as in Figure 7. The moving bicycle has mechanical energy. What happens to this mechanical energy when you apply the brakes and the bicycle stops? When you apply the brakes, the bicycle's mechanical energy is not destroyed. Instead, the bicycle's mechanical energy is transformed into thermal energy, as shown in Figure 7. The total amount of energy never changes. The additional thermal energy causes the brakes, the wheels, and the air around the bicycle to become slightly warmer. Friction is a force that resists the sliding of two surfaces that are touching. Friction between the bicycle's brake pads and the moving wheels transforms mechanical energy into thermal energy. Key concept check. Friction causes what energy transformation? There is always some friction between any two surfaces that are rubbing against each other. As a result, some mechanical energy is always transformed into thermal energy when two surfaces rub against each other. It is easier to pedal a bicycle if there is less friction between the bicycle's parts. With less friction, less of the bicycle's mechanical energy gets transformed into thermal energy. One way to reduce friction is to apply a lubricant, such as oil, grease, or graphite, to surfaces that rub against each other. Using energy. Every day you use different forms of energy to do different things. You might use the radiant energy from a lamp to light a room, or you might use the chemical energy stored in your body to run a race. When you use energy, you usually change it from one form into another. For example, the lamp changes electric energy into radiant energy and thermal energy. Using thermal energy. All forms of energy can be transformed into thermal energy. People often use thermal energy to cook food or provide warmth. A gas stove transforms the chemical energy stored in natural gas into the thermal energy that cooks food. An electric space heater transforms the electric energy from a power plant into the thermal energy that warms a room. In a jet engine, burning fuel releases thermal energy that the engine transforms into mechanical energy. Using chemical energy. During photosynthesis, a plant transforms the sun's radiant energy into chemical energy that it stores in chemical compounds. Some of these compounds become food for other living things. Your body transforms the chemical energy from your food into the kinetic energy necessary for movement. Your body also transforms chemical energy into the thermal energy necessary to keep you warm. Using radiant energy. The cell phone in Figure 8 sends and receives radiant energy using microwaves. When you are listening to someone on a cell phone, that cell phone is transforming radiant energy into electrical energy and then into sound energy. When you are speaking into a cell phone, it is transforming sound energy into electric energy and then into radiant energy. Using electric energy. Many of the devices you might use every day, such as handheld video games, MP3 players, and hair dryers, use electric energy. Some devices, such as hair dryers, use electric energy from electrical power plants. Other appliances, such as handheld video games, transform the chemical energy stored in batteries into electric energy. Key concept check. What happens to energy when it is used? Waste energy. When energy changes form, some thermal energy is always released. For example, a light bulb converts some electric energy into radiant energy. However, the light bulb also transforms some electric energy into thermal energy. This is what makes the light bulb hot. Some of this thermal energy moves into the air and cannot be used. Scientists often refer to thermal energy that cannot be used as waste energy. Whenever energy is used, some energy is transformed into useful energy, and some is transformed into waste energy. For example, we use the chemical energy in gasoline to make the cars in Figure 9 move. However, most of that chemical energy ends up as waste energy, thermal energy that moves into the air. Reading check. What is waste energy?